Right now, something from another star system is leaving our solar neighborhood, and we almost missed it entirely. In July 2025, a telescope in Chile caught a faint smudge of light drifting through the outer asteroid belt. Within hours, astronomers around the world realized what they were looking at. This was not a comet born in our solar system. It was a visitor, a traveler from the deep galaxy, carrying materials forged around a completely different star, billions of kilometers from here. Its name is 3I Atlas, and it has already changed everything we thought we knew about the universe next door. My name is FD, and you are watching Universa Stuff. In all of human history, we have only ever confirmed 3 objects that arrived in our solar system from interstellar space. Out of the billions of comets and asteroids orbiting our sun, only 3 times have we caught something that came from somewhere else entirely. The first was Oumuamua in 2017, a strange, elongated, tumbling object with no visible tail, no gas, no coma, that defied every category astronomers had. The second was 2I/Borisov in 2019, the first confirmed interstellar comet, more familiar in behavior but still alien in origin. And now there is a third. Comet 3I Atlas, bigger than either of its predecessors, more active, more chemically bizarre, and watched for the first time by more telescopes than any interstellar visitor in history. Today we are going to follow this extraordinary object, from its discovery in the Chilean desert, across the inner solar system, past Mars, around the Sun, and back out into the galaxy from which it came. By the end of this video, you will understand why scientists around the world called it one of the most important objects of the decade. On the first day of July 2025, the Atlas Survey Telescope, a system designed to protect Earth from asteroid impacts, was scanning the sky from Rio Hurtado, Chile, when it recorded something unusual in 4 consecutive images. An object moving fast, too fast. Within 24 hours, astronomers had enough data to trace its path back through space. The trajectory was hyperbolic, meaning it could not have originated from within our solar system. It was not orbiting the Sun. It was passing through, on a one-way journey from somewhere else in the Milky Way. The pre-discovery data made things even more striking. The Zwicky Transient Facility in California had actually photographed this object as early as June 14, 2025, without recognizing what it was. 3I Atlas had already been in our solar system for weeks before anyone noticed. You might wonder, how do astronomers actually know this comet came from another star system? The answer comes down to speed and trajectory. Everything in our solar system, every planet, comet, and asteroid, follows what is called a closed orbit. Bound by the Sun's gravity, it loops around and comes back. But 3I Atlas follows a hyperbolic orbit, an open curve. Trace it backward through time, and it does not lead back to the outer solar system. It leads out into the galaxy. When it was discovered, 3I Atlas was already traveling at approximately 137,000 miles per hour, about 221,000 kilometers per hour. That is far faster than any object born in our solar system should be moving at that distance. As it swung around the Sun's gravity accelerated it even further, briefly reaching 153,000 miles per hour at closest approach. And when it leaves, it will carry that same interstellar speed back out into the dark. One of the first questions astronomers asked, how big is it? Using data from the Hubble Space Telescope in August 2025, they estimated the nucleus is somewhere between 440 meters and 5-6 kilometers in diameter. That range is large because the comet was already developing a thick cloud of dust and gas, called a coma, which made it difficult to see the nucleus directly. And that coma itself was a surprise. For an interstellar object, 3I Atlas was extraordinarily active. As it approached the Sun, it shed dust at an estimated rate of between 0.3 and 4.2 kilograms every single second. That is comparable to the activity of a weakly active comet from the outer edges of our own solar system, behavior nobody expected from a visitor from interstellar space. Hubble images showed a distinctive teardrop-shaped cloud of dust surrounding the nucleus. No classic ion tail at first, which puzzled researchers, though later observations confirmed the comet did develop both a normal dust tail and a remarkable anti-tail, a short spike pointing back toward the sun. This is where things get truly strange. When the James Webb Space Telescope turned its infrared eyes on 3I Atlas, it detected something remarkable in the comet's coma. The ratio of carbon dioxide to water ice was approximately 8:1. 8 molecules of CO₂ for every molecule of water. In any solar system comet, that ratio is tiny. This was one of the highest CO₂ to water ratios ever recorded in any comet anywhere. What does that tell us? It suggests that 3I Atlas formed in a very cold environment far from its home star, in the equivalent of our own Oort cloud. The extreme cold preserves high concentrations of carbon dioxide ice, which then sublimes explosively as the comet approaches a warm star. On top of that, spectroscopic analysis revealed the comet's dust had slight organic reddening, similar to the trans-Neptunian objects at the far reaches of our own solar system. And polarimetric measurements, the study of how light vibrates as it bounces off the comet, produced results completely unlike anything seen in a solar system comet. Scientists described the polarization signature as unprecedented. 3I Atlas may represent an entirely new class of small body in the universe. Where did 3I Atlas actually come from? Using the comet's speed, trajectory, and the statistical models developed for tracking stellar populations in the Milky Way, astronomers traced its most likely origin to what is called the Galactic Thick Disk. This is an older population of stars that formed in the early Milky Way, stars that are on average 8 to 10 billion years old. Our Sun, by comparison, is about 4–6 billion years old. If correct, this would make 3I Atlas the oldest interstellar visitor we have ever recorded. Materials inside its nucleus may have formed when the Milky Way itself was still young. The atoms in that comet have been traveling through space for longer than our entire solar system has existed. For the first time in history, humanity had enough assets spread across the solar system to track an interstellar visitor from multiple angles simultaneously. NASA pointed Hubble, Webb, TESS, Swift, SPHEREX, and Parker Solar Probe at 3I Atlas. The Mars Reconnaissance Orbiter imaged it from orbit around Mars. The Perseverance rover photographed it as a faint smudge in the Martian sky on October 4, 2025, the first time an interstellar object had ever been observed from the surface of another planet. Europa Clipper, Lucy, Psyche spacecraft on their way to entirely different targets all took time to swing their cameras toward this comet. Even the Parker Solar Probe, deep inside Mercury's orbit, tracked it during the weeks when the comet was hidden from Earth by the sun's glare. When 3I Atlas finally reappeared on the other side of the sun in December 2025, Hubble photographed it again. The comet was still active, still shedding material, still letting us read the secrets of another star system. Now, it would not be honest to do a video about 3I Atlas without mentioning the question that surfaced immediately when it was discovered. Could it be artificial? Harvard astrophysicist Avi Loeb noted that the comet's path happened to align closely with the orbital planes of Venus, Mars, and Jupiter, which he argued was statistically unusual for a random trajectory. He proposed, speculatively, that 3I Atlas could be a technological object from another civilization. The scientific community responded with careful analysis. The comet's behavior, its coma, its gas emissions, its dust, all match perfectly what we expect from a natural comet. The alignment with planetary orbital planes was later shown to be within the expected statistical range for interstellar objects. The conclusion, 3I Atlas is a comet, not a spaceship. But the fact that we are now advanced enough to ask that question seriously and answer it with data is itself a remarkable sign of how far our science has come. Here is the thought that should stay with you long after this video ends. 3I Atlas has now left our solar system. It will never return. But it has left something behind, something invisible but permanent. As it shed dust and gas throughout its journey through our solar neighborhood, some of those tiny particles, atoms and molecules forged around a different star will have been captured by our sun's gravity, scattered across the solar system, Some may even settle eventually onto the surfaces of planets. Molecules from another star system are right now, part of our solar system, perhaps part of our world. And here is the part that will genuinely stop you in your tracks. Scientists estimate that interstellar objects like 3I Atlas may pass through our solar system as often as once per year. We simply did not have the technology to detect them until now. The universe has been seeding us with material from other stars our entire existence, and we are only just beginning to notice. 3I Atlas arrived silently, crossed our solar system in months, and departed carrying with it material that will never be ours to study again. But what it left behind in our data archives, in our understanding, in the questions it raised about life and chemistry across the galaxy will take astronomers decades to fully process. We live in an extraordinary moment. For the first time in history, we have the eyes to see the universe talking to us, and we are finally learning to listen. If you found this video fascinating, subscribe to Universa Stuff for a new journey through the cosmos every week. And next time, we are looking at the James Webb Space Telescope's most groundbreaking discovery yet, the earliest black hole ever confirmed, found just 570 million years after the Big Bang.